Good morning to everyone. I am Sai Pawan from CSAML department, bearing roll number 23951A6667. And today I am here to discuss about the protocol of multi-hop wireless network in the subject of computer networks. And without any delay, let's get start our session. And yes, introduction part. On the introduction of protocol for multi-hop wireless networks, here is the overview of multi-hop wireless networks, where importance in modern communication and examples like mobile ad hoc networks, wireless sensor networks, WSNs, and role in extending wireless coverage and comparison with single hop networks and etc. And wireless networks generally enables communication without wide infrastructure and types of infrastructure based on Wi-Fi, cellular, and ad hoc multi-hop manets used in IoT, smart cities, disaster response, which requires efficient routing strategies and security concern in wireless communication. Yes. Generally, what is a multi-hop wireless network is of generally our a network where data is relayed through multiple intermediate nodes, which the nodes act as both transmitters and as well as receivers. In common words, in manets, WSNs, and IoT applications, generally these multi-hop wireless network is used, and it also enhances coverage without increasing transmission power, and it also improves network scalability, where we can see in the diagram itself various depth positions in various levels, and S2 which cluster head located near the sink, and S3 the cluster head requires multi-hop transmissions, and so on up to 8 is 8. And the need of multi-hop wireless network in our daily lives as well as in AI networks extend network coverage behind single hop range and improves energy efficiency in sensor networks. It also enables communication in areas without infrastructure, support mobile and dynamic environments, reduces interface by lowering transmission power. And the applications of multi-hop wireless are there are various applications from multi-hop wireless like disaster recovery and emergency response, military and defense communications, smart cities, IoT and remote sensing areas, and environmental monitoring and tracking. And it also uses in healthcare and wearable devices. These are the general and daily life applications where we use multi-hop wireless networks and challenges in multi-hop wireless networks. The challenges in multi-hop wireless networks are high latency due to multiple hops and security threats. When it comes to security, it generally involves dropping DOS attacks and energy constraints in battery operated nodes. Frequent topology changes due to mobility, limited bandwidth, and congestion issues. These are some of the challenges where we have to face while using multi-hop wireless network. And types of routing protocols. The types of routing protocols are proactive, table driven, maintains routing table, reactive on demand, finds route when needed, hybrid, combination of both proactive and reactive, geographic based routing for efficient packed delivery, cluster based routing for load and balancing. And in the diagram, we can see where uh, trusted authority is connected between roadside cloud and RSU local server, where from local server the users are getting the network from various areas like local servers and roadside cloud servers. And proactive table driven protocols. Generally, the proactive table driven protocols maintains up to date routing tables. Example, OLSR which is optimized linked state routing, and DSDV, which stands for destination sequenced distance vector. These are the examples that comes under proactive table driven protocols, which maintain up to date routing tables and higher overhead but low latency. And these are also good for stable networks with frequent communication. And there is a huge issues about the scalability in large network. So as we face challenges in the scalability also itself, as we don't get more scalability of these type of protocols. And reactive or on demand protocol. Reactive or on demand protocols generally routes are established only when needed. Examples, AODV, ad hoc on demand distance vector, and DSR, which stands for dynamic resource routing. These are generally lower overhead but increases latency, and it is also efficient to use and for highly dynamic networks. Route discovery and maintenance mechanisms. Hybrid routing protocol combines proactive and reactive features is known as hybrid routing protocols, where the example will be zone routing protocol. It uses proactive routing for nearby nodes and reactive for distant nodes, reduces overhead while maintaining scalability, and suitable for large and complex networks. Key multi-hop routing protocols. The key multi-hop routing protocols generally AODV, which established routes on demand, and DSR user source routing with route caching, and OLSR proactive link state protocol, and DSDV table driven protocol with sequence numbers. These are the key multi-hop routing protocols which we often see in multi-hop routing protocols. And coming to DSR, dynamic source routing protocol. It generally uses source routing with route discovery and maintenance. Each packet carries the complete route, which is efficient for small to medium networks. And it also uses route cache to store discovered routes and eliminates the need for periodic route updates. And OLSR, optimized link state routing protocol. The protocol that uses multi-point relays and reduces control message overhead and efficient for dense network, and also maintain link state information at each node with periodic message exchange ensures updated routes. And case study, future trends in multi-hop wireless protocol. AI driven adaptive routing, blockchain for secure routing, energy efficient and self organized networks, and integrating with space and underwater communication networks. And case study scenario, communication failure after a disaster, uses sensor nodes to locate survivors. Real time monitoring and coordination is the case study of this multi hop monitoring system. And conclusion, future research directions, final thoughts on multi hop wireless networks.